Okay. Who's got some? Hit me. Freshman in community time, we're playing some shadow boxing game. Is that now the rage? It looks really dumb, I gotta say. His assignment center wasn't bugged.
Hey, Tank Davis on top.
Hey, when's the TOK redo?
Anybody got one?
Number 4.
Sure. Number 4.
Part 2 is done for TOK, right? Oh, tomorrow we get that part 2.
Seriously?
Maybe, I don't know.
I didn't do it.
It probably is.
I have no idea.
All right. So here it asks for the domain. So since the division problem, I know the domain is going to be everything except where the denominator is equal to 0. To solve that, I'm going to solve it by factoring. So I get that x cannot equal 7 or x cannot equal -2. And now I'm going to write that as an interval because typically we're going to write our domains as interval notations. So I have -infinity up to -2, and then I have -2 to 7, and then I have 7 to positive infinity, which would be everything except for -2 and 7. Does that feel okay? I busted through it, but if you're good, I'm good, we're good. That's good. Who else has some questions? Kendall, are you trying to ask about something? Okay, we'll let you think. Who'd I cut off? Was it you, Morgan?
Yeah.
10. Let's look at 10. So 10, we're looking at this picture. Let me drop this in real quick. Bloop. All right. So here it says the limit as x approaches 1 with that negative sign in the exponent. What does that negative sign in the exponent mean? It means left. So we're approaching 1 from the left, which means we're looking at like this part of our function. Is that okay? So what direction is that pointing? What direction is the graph pointing? That yellow direction I've highlighted? Up, which would be then positive infinity because it's pointing straight up. That's it. That's all you had to do. You're just looking at the picture. Is that okay?
Yeah.
Okay. I mean, I can explain more, but it's like, just keep it simple, right? Like if that's all we're doing, okay, I can handle that. Others. Seven. Yeah, I can do it. Okay. Bloop. It says find the vertical asymptote. So how do I do that? Well, first things first, I should try to factor this thing, right? Just to make sure that there's no removable discontinuities. Multiplies to give me positive 6 and adds to give me negative 5. So there's that. So there's nothing to cross out, right? There's no removable. So the vertical asymptotes are just going to be the denominator set equal to 0. So since it's factored, I can probably just write them down. It's easy to do that part in our head. Horizontal asymptotes. Well, since the degree is the same, I know the horizontal asymptote should be leading coefficient, which is 1, over leading coefficient, which is also 1. So 1 over 1 is just 1. The zeros is just where the numerator set equal to 0 and solved. So again, I'll just do that kind of quickly in my head. And then the y-intercept is just me plugging in 0 for x, so all I'd have left is the constant terms. So 16 over 6, which reduces down to 8 over 3. It says you don't need to graph it, so I think we're done at that point.
Yeah.
Is that cool?
Yeah.
Okay. Pretty easy.
Yeah. I just need to, like.
Yeah, that's okay. You can have a refresher. Refreshing drink of section 14.1. All right, what do you guys think? We good to go to the next section? Move it on? Okie dokie. I'm good if you're good.
I'm good too.
You're good?
Yeah.
That's good. All right. So in section 14.3, we're going to look at solving inequalities. And when we say solving inequalities, we really are talking about like polynomial and rational function inequalities, or even stuff more complicated than that. Now, you remember when we solved linear inequalities way back in like Algebra 1? That was real easy, right? It wasn't really any different than solving solving an equation other than like you had to remember to flip the inequality symbol if you divide by a negative kind of thing. Whoop-de-doo-doo! With the polynomial inequalities and rational function inequalities, it's a little bit more complicated than that. So we're going to approach it at a decidedly different way. So here we have x squared minus 4 is greater than 0. So I'm going to start by just finding out where this function is equal to 0 at. So I could solve this equation. I could add 4 to both sides and then square root. I could factor, which is the way I'm writing it now. Or I could like use the quadratic formula. Whatever you're doing, you just need to find out what those zeros are, the place where the function is equal to 0. Because I know that a polynomial is continuous. So the only places where the polynomial can change from positive to negative is at one of these zeros, right? And I'm asked for when is the polynomial positive, right? So I've got that. So what I'm going to do now is I'm going to draw what's called a sign diagram, S-I-G-N-E. We're in trig and pre-calc, so I have to be careful when I say sign. So I've drawn the sign diagram and I've just kind of placed the two zeros on the sign diagram. First thing I want to do is figure out if those zeros should be included in my solution or not. So is negative 2 and positive 2 part of the solution for x squared minus 4 greater than 0?
No.
No is the answer. Why not?
Because it's not equal to, it's just great.
It's a strict greater than, so the zeros will be not included. So I'm going to use an open circle, just like when I graphed inequalities way back when, just to remind myself that those are not part of the solution set. Everybody's cool so far? Then what I'm going to do is I'm going to pick a test value inside of each of these 3 intervals that I've created, right? I have interval here, here, and here. So I'm going to pick a value that's less than -2, so maybe -3. A value that's between -2 and +2, well, how about 0? And a value that's bigger than 2, how about 3? And then I'm going to just plug those into my function and see what the result is. And I don't even really care what the number is for the result. All I really care about is whether the result is positive or negative. And usually when I plug them in, I plug it in here to the factored form. So -3 minus 2 is negative. -3 plus 2 is negative. Negative times negative is positive. If I plug 0 in, 0 minus 2 is negative. 0 plus 2 is negative times positive is negative. And again, you can plug these in kind of anywhere you want. You could find the actual number. If all I care about is the sign, I'm just going to do this kind of minimally where I can do it in my head. But if you don't feel comfortable with that, you can certainly do more, right? All right, our last one. Plugging in 3. 3 minus 2 is positive. 3 plus 2 is positive. Positive times positive is positive. All right. Now, what parts of this sign diagram do I want? What am I trying to find? Trying to find where x squared minus 4 is greater than 0. So what parts of the sign diagram do I want? The positive parts, because it's greater than 0. So those are the 2 pieces I want. So I'll say I want the x's from -infinity to -2, and from 2 to positive infinity. Does that feel okay to everybody? This is what the entire lecture is going to be. I'm just going to go through and kind of do some examples and see some of the kind of things to watch out for when you're doing this. But this is the basic procedure right here. So you set the thing equal to 0, and then you draw your sign diagram, and then you pick some test values and kind of figure out what you need. Now, could it get a little bit more complicated than that sometimes? Yeah, maybe, but it's not so bad. It's still basically the same process. All right, so here again I have a polynomial. This polynomial is a little bit more complicated because it's a degree 3 polynomial. How many zeros could I have at most here? 3, since it's degree 3. So I'm going to just start by setting it equal to 0, just like I did before. And how am I going to factor this? What do I want to start by doing? Take out an x, yep. And then I notice that x squared minus 4x plus 4 is factorable. How does it factor? Excellent, thank you, sir. So when I solve, then I get 0, 2, and 2, right? So go ahead and draw our sign diagram. Now, notice that I only put 2 on there once because getting the same solution twice is just 2 solutions, right? All right, first thing I do now that I've drawn my sign diagram is try to decide whether 0 and 2 belong in the solution set. Should I use a open circle or a closed circle for 0 and 2? Closed, because it's an or equal to inequality. Great. What test value should I pick? Some -1. Then how about between 0 and 2? 1. How about bigger than 2? Those all sound good to me. Now I'm going to just plug them into my factored version and see whether the result is positive or negative. So I got negative 1. Well, when I plug negative 1 in for x, I get negative. I plug it into x minus 2, I get negative. And I plug it into x minus 2, I get negative. 3 negatives is negative. Okay. I plug 1 into x, I get positive. 1 into x minus 2, I get negative. 1 into x minus 2, I get negative. 1 positive and 2 negatives is positive. And then I'll plug 3 in for x, that's positive. 3 in for x minus 2, that's positive. 3 in for x minus 2, that's positive. 3 positives is a positive. Okay? So what part of this am I going to be interested in here? Right, I have x cubed minus 4x squared plus 4x less than or equal to 0. What parts am I interested in? When on the sign diagram, what parts of my sign diagram are we interested in? The negative part, right? Almost.
Oh, I get it.
What else do I need?
The dot, the 0.
Yeah. 2 also works, right? Everybody's okay with y? Because the function is equal to 0 at 2 also. So how do I write this using my interval notation? Well, I'll write, negative infinity to 0 with the bracket, right? What's the bracket mean? It means it's included, because I used a filled in circle for the 0 is why I'm using a bracket on the 0. And then how do I just write a single number? That's not an interval, right? That's not a set of points. So I'm not going to use interval notation to write 2. I'm just going to use regular old set notation, use those squiggly brackets. We okay there? Okay. All right. Let's see what happens here. Ooh! X minus 4 over x plus 1 is greater than or equal to 0. So I'm still going to start the same way. I'm going to set this equal to 0. When is a fraction equal to 0? When the numerator is 0. Good. But a rational function is distinctly different than a polynomial function. A polynomial function is continuous everywhere. A rational function can have discontinuities, right? Like a vertical asymptote or something. And you've noticed on a vertical asymptote, sometimes we have like one side of the vertical asymptote, the function is pointing up. The other side of the vertical asymptote, it's pointing down. So we can change sign also, not only at an x-intercept, a 0 for the function, but also at a discontinuity. So we have to include those when we do our sign diagram. And how do I find the discontinuities? Well, I set the denominator equal to 0. Everybody okay with what I did there? So if you have a rational function, you have to set both the numerator and the denominator equal to 0. So I'll draw my sign diagram. For the 0, x equals 4, should I use a open or a closed circle? Closed. Why? Good, because if it's an or equal to inequality. For the discontinuity, -1, should I use an open circle or a closed circle? That's incorrect. It is going to be open. Why has it got to be open? It's a discontinuity. That's not part of the function's domain. Regardless of what kind of inequality you have, the discontinuities will always be open circles because there's no point there. That's not an x value that could be a solution. Everybody's okay with that? Okay. So now I'll just pick some test values. So maybe -2 for something less than -1, 0 for something between -1 and 4, and 5 for something bigger than 4. Again, there's nothing magic about these numbers. You can use any numbers you want, but like, don't make it harder than it needs to be on yourself. Don't pick like, 7/3 or something. Like, yeah, why do that? Just pick something nice and easy, if you can. All right, so I'm just going to be plugging into the function. So -2 minus 4 is negative. -2 plus 1 is negative. Negative over negative is positive. 0 minus 4 is negative. 0 plus 1 is positive. Negative over positive is negative. 5 minus 4 is positive. 5 plus 1 is positive. Positive over positive is positive. And which parts of my sign diagram do I want? Do I want the negatives or the positives? Because we're greater than 0, we want the positive parts. So we'll go from -infinity to -1, and that's going to get a parenthesis. And then we'll go 4 to positive infinity, but the 4 gets a bracket. So far, so good? Getting the idea? It's not too bad, right? I kind of like this, is that it's very visual. I'm a visual kind of person. Like, that always makes a lot of sense to me when I can, like, take something that's really abstract and turn it into something where I have, like, a visual framework for it. Those of you guys that are planning on taking calculus next year, we do a fair bit of sign diagram stuff in that course as well. So you'll see these kind of notation ideas again. All right. Last example here. So we have solve the inequality square root x plus 4 divided by absolute value of x plus 1, and that's greater than 0. So again, we'll start by finding the zeros. So I'm just going to take the numerator, set it equal to 0, square both sides, and then subtract the 4. And then I have my discontinuities. That happens where I take the denominator and set it equal to 0. Refresher here, when I solve an absolute value equation, how do I do that? Yeah, so I rewrite this as two equations. So one equation is just I drop the absolute value, everything else stays the same. And the other equation is the left-hand side stays the same, but I negate the right-hand side. Now the negative of 0 is still just 0, so I just have one solution here, just x equals 1. But that just gives me a good opportunity to review how to do that. I'm guessing that most of us have taken are planning on taking ACTs again here sometime. That's a common question that'll come up on there, like having to solve an inequality. Or a absolute value equation. All right, so pick some test values. All right, should the -4 be an open or closed? Open. Should the 1 be open or closed? Open. Are they open and closed for different reasons?
Yes.
Yes. The -4 is open because it's a strict greater than inequality. The 1 is open because that's a discontinuity. All right, let's plug some stuff in. If I plug -5 in, the square root of -5 plus 4 is square root of -1, which is non-real, right? So that does not count as negative or positive. I'm just going to write no real solution there. That'll not be part of either, whether, regardless of whether that was a greater than or less than inequality. The imaginary parts don't count for either. Everybody's okay with that? Okay. If I plug 0 in, square root 0 plus 4 is
4.
positive. It's actually 2.
Wait, what was the question?
Square root of 0 plus 4. What's the square root of 4?
Oh, I thought
Which-
you were saying the square root of 0 and then plus 4.
Oh, yeah. Anyways, and then absolute value 0 minus 1 is positive. Positive over positive is positive. Square root 2 plus 4 is
Square root 2.
positive, right?
Oh, yeah.
We don't really care what that is. And then 2 absolute value 2 minus 1 is positive. Positive over positive is positive. So, how many intervals do I have for my solution here? I should have 2. It's really tempting to write that as one inequality or one interval, but it is not. It is 2 separate. I got to go from -4 to 1 and then 1 to positive infinity. But that's all she wrote there. What do you guys think on this? It's not too bad, right? Again, probably new. You probably did not do this in your Algebra 2 class, but like, this is not a big deal. So at this point, you guys should be able to do up through 57, I think. This is actually the last section in chapter 14, but I'm going to do an additional section also. So next time, what haven't we done for chapter 14 yet that we do for most chapters? I would expect to see that. So up through section 2, so solving equations, I think is probably fair game. What we did today would be off the table for the homework quiz. And then we'll do the one more section that I want to do. That section is called partial fraction decomposition, which is, boy, that's a mouthful, but it's not that bad. And then on Friday, we'll do the review day, and we'll be taking the test like Tuesday next week. Unless there's like is that the crazy AP day where everybody's gone? Oh, you guys are in the afternoon anyway. Well, what day is the AP comp thing? That's the thing that you guys all have, right? That's like the 8th. Let me look here. So that would be that Tuesday, right?
It's not the third. That's the second.
Oh, okay. May 2nd is next week then, right?
No, that's not the.
What's today's date? 24. Okay, so Tuesday would be the 2nd, so that's not a big deal.
No.
The week after that, okay. I just wanted to make sure that I wasn't putting the test on a day where you guys all had the AP test.
Wait, I didn't find.
Is the test like
This year, they're, multiple question
It would be like next Tuesday, like the 2nd or something, which should not be a big conflict for everybody. There might be like 1 or 2 people that have something.
Yeah, some sort of before there'd be like a math homework. Like you guys like figure it out, like do the math again. That's too harder issue.
Okay.
We actually fell.
So the half one is if it's automatic, like that. And it also does it add up for like the age?
Okay. Shh. If you guys want to just do it on, if you want to do it on Thursday and just have a regular class on Tuesday, that's fine. Does that make it easier? I know they're all and all the days are going to be kind of bad. I just don't want to be like, I don't want to pick something that's like just a dumb day to do it. Like there's going to be no good day to do it. Well, let's not do it on a really dumb day, right? Is that preferable to do Thursday and just do regular class on Tuesday? Or does it matter? Okay, so you're telling me to move it? I'm happy to do that. That's fine. Thursday then.